Actually really quite an easy lesson though. Okay, because in 1010 we spend a lot of time graphing. Now here's the important thing for the notes here. We're first of all going to just get really familiar with all the different types of graphs and remembering how to graph things. And we're really just going to do it by plotting points for the most part. So everybody looking at this, f of x is equal to x squared. You need to be able to see that and right away know, isn't an x squared a u-shaped graph? That's what you should know. That's what you should write down. Honestly, that's the only thing you really need to write down in your notes. X squared is a perfect u. A smiley face or brownie face. And then from there, just plot points. Now think about it. Quadratics don't have any restrictions, so we can plug in anything, correct? We can plug in anything. So let's just plug in the usual 5 points. -2, -1, 0, 1, and 2. -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. I don't expect you to take notes on like graphing a quadratic because you know how to do it, so just watching. 0, 0, -2 up 4, -1 up 1, over 1 up 1, over 2 up 4. So the main thing to get out of this is we know how to graph a quadratic by plotting points. Quadratics are U-shapes. All good with that. Pretty easy stuff, right? Okay, moving on to the next type of graph. There is a reason we're going over all the graphs, because then we're going to put it all together. So x cubed. Now think about it, guys. If you're like, well, what x, y point should I graph? Is there any restrictions on x cubed? No, we can plug in anything. So just the same old, -2, -1, 0, 1, and 2. Now, -2 to the third power, or -2 cubed, is -2 times -2 times -2, which is -8. -1 cubed is -1, 0 cubed is 0, 1 cubed is 1, 2 cubed is 8. So watching me graph that, 0, 0, over -2 down 8, over -1 down 1 unit, over 1 up 1, over 2 up 8. Something cubed looks like this. Kind of a squiggly line. It's not a line, it's not linear, but a squiggly line. Everybody good with that. So that's what an x cubed graph looks like. That might be something you put down in your notes, is the rough sketch of an x cubed graph. Alright, square root of x. Now this one we cannot plug in anything because we can't plot imaginary points. Isn't it true we learned last time that our domain will be whatever's underneath, which is x, needs to be greater than or equal to 0. That's our domain of this, right? If you did your homework last time, that's very easy. True? So isn't then, what's the first value we'll plug in if that's the case? 0. Are we with me, people? Yes? Focus. Plugging in 0. What's the square root of 0? 0. Square root of 1. 1. Square root of 2 is a decimal. I'm not going to choose that point. Square root of 3, decimal. Square root of 4. Square root of 9 will be the next one, 3. So plotting points, 0, 0, over 1 up 1, over 4 up 2 units, over 9 up 3 units. So there is our square root graph. That's what a square root graph looks like. Alright, so then with a line 2x plus 1, we can plug in anything. We can plot points. But honestly, guys, I'm not going to graph lines like that. To me, it's easier to know how to graph a line with y-intercept and slope. So just a reminder, this mx plus b, this is our y-intercept. So it's crossing at +1. Is everybody good with that? Our slope is 2, which is 2 over 1. Rise over run. Now understand, you always go to the right with your run to start out. So everybody, I'm going up 2 units, rising 2, to the right 1. Up 2 over 1, up 2 over 1. And now to connect the line, yes, now I need to go backwards, so down 2 over 1. Down 2 over 1, down 2 over 1, down 2 over 1. You could plot points or just use your knowledge for a line, but to me it's easier just to do mx plus b graphing. You agree? Alright, so you know how to graph a line. Okay, let's look at an absolute value function. Just a reminder, an absolute value function, it's been a while since we graphed these, are sharp V's. Now these V's are kind of like lines, they have slopes. So, but yeah, we could just plot points. We can plug in anything to an absolute value. So -2, -1, 0, 1, 2. The absolute value of -2 is 2, positive distance. So we plug in something into an absolute value, it's positive, right? So -1, 1, 0, 0. Absolute value of 1 is 1. Absolute value of 2 is 2. So -2 up 2, -1 up 1, 0, 0, over 1 up 1, over 2 up 2. Now as you can see, guys, look, no shift left and right, no shift up or down. Do you agree? So that's why we're at 0, 0. And then isn't it this right here is what the slope is? So our slope is 1 over 1. So look, it's up 1 over 1, up 1 over 1. So I could keep plotting points or use that knowledge. Up 1 over 1, up 1 over 1, and so on. So absolute values are sharp V's. You gotta remember that. Does that make sense? Okay. Moving on. Graphing a straight line of 3. Now guys, f of x is y. So this literally says y equals 3. Well, if y is always equal to 3, it doesn't say anything about x. X can be anything. So if x can be anything, but y is always 3, think about plotting points. Over 0 up 3, over 1 up 3, over 2 up 3. Do you guys see what's happening? Over negative 1 up 3. It's a straight line at positive 3. There's your function. So what if it would have been f of x equals negative 2? Wouldn't we have just had a straight line at negative 2? Like that. Alright, and then graphing this, honestly, we're really not going to be spending a lot of time graphing these in this particular lesson, so I'm almost inclined just to skip this example. I just want to ask you, what's the domain? X cannot be 1. That would make the denominator 0. So our domain would have been negative infinity up to 1. Then it would jump over 1 and go from 1 to infinity, wouldn't it? Because that would connect us through, union 1 to infinity. Okay, we're not going to spend a lot of time graphing in rationals in this particular lesson. Later in the year we will. Alright, now we'll get into, the reason we went over all that is to be able to do this. This is where the lesson truly starts. Graphing piecewise functions. Now piecewise functions literally are exactly what the name says. Pieces of different functions in one graph. So on this one XY chart right here, we're going to graph a quadratic and we're going to graph a line. Now we're just graphing pieces of the quadratic and pieces of the line. So what I want you to notice is, look, we have two functions, so we have x squared. Let's graph it. So xy, if we made an xy chart, we know negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and we can plot more points than that if need be. So everybody, negative 2 up 4, negative 1 up 1, 0, 0, over 1 up 1, over 2 up 4. Now watch me graphing this. I've graphed the entire quadratic, which is actually not what it says to do. So I graph it first, but now I'm going to erase it accordingly. Now look, it says graph the quadratic for all the x values less than or equal to 1. So everybody look what I do. I go to the x value of 1. Do you see how I'm at the x value of 1? Locate the function. Isn't it right there? Yes? You're only going to keep the quadratic for x values less than, below that, notice the arrow's pointing that way. You're keeping the x values for you're keeping the quadratic for x values less than or equal to 1. So what I need to do is erase all the quadratic for the above values, for the x values above 1. Do you guys see? So that we're only graphing a piece of the quadratic for x values less than or equal to 1. Now because of the equal sign, I have a closed circle. At 1, the function has a closed circle. Do you have questions for that? Because it says greater than, less than or equal to 1. So it includes 1. The quadratic includes 1. And now we're just going to literally ignore that. Ignore the quadratic, start our thinking process over. So graphing 2x plus 1, there's our y-intercept. I'm just going to do dots for right now. Our y-intercept is at positive 1, and then our slope is 2 over 1. So look, rising 1, 2 over 1, up 1, 2 over 1, up 2 over 1. Now if I were to connect it all the way through, that would be fine, but I'd have to erase, so I'm not going to connect quite yet. Aren't we only graphing the line for x values above 1, greater than 1? So what I'm going to do, watch, I go to the x value of 1, locate where our function is. Doesn't it start right there? The blue function starts right there. And it's for x values greater than 1, so that would be this way. Notice the arrow points that way. We're keeping that side of the line. So now it says, but not including 1. There wasn't an including sign. I just personally underlined it twice, but it wasn't including. It was just x values greater than 1. So what I got to do is go to 1, locate the function, not including the function at 1. So I've got to open up my circle. And then I'm going to erase that little dot. So it's the pieces of the function. There's a piece of the quadratic, a piece of the line. Now notice, you will know you graphed these correctly quite easily because it should pass the vertical line test. If you've double dipped somewhere, if they're overlapping, you've done something wrong. Look, if I trace through right here, do you see how it never overlaps? Once it gets to 1, do you see how I have a closed circle and open circle? So it's never overlapping, and then it continues on forever. So you'll know you've done something wrong if you have two open circles on top of each other. If this was like overlapping this red function, you graphed something wrong. Or if you have two closed circles, something's wrong because it will be a function. Pretty easy as long as you know what you're doing. Let's do another example. All right, so this one has three pieces, an absolute value, a quadratic, and a line. So let's just focus on piece number one. The absolute value of x. So if I needed to make an xy chart, we could, but also we know how absolute value functions work. There's no shift left and right, no shift up and down, right, everybody? So 0, 0 would be our starting point. And then my slope is 1. So up 1 over 1, up 1 over 1. What do absolute value graphs look like? A V. So we're not going to continue down. We're going to go back up. It's a V. Okay, if I were to connect that, great. Here we go. Now it should say, my fault here, I've messed up on this. And this, I don't know what the heck was going on. Okay, so we're keeping this absolute value function for x values less than or equal to 3. Negative 3. Sorry, I couldn't see it with my pen in the way. So watch what I do. I go to negative 3. Find the function. It's right there. Does everybody see? We're keeping it for values below negative 3. So I'm keeping the below. Now, it's or equal to, so I have a closed circle at negative 3. Now I've got to erase the above because we're not keeping the absolute value functions for x values above negative 3. Any questions on that? Okay, moving on. Now we have the quadratic. Let's do red. We have x squared. Now look at the xy points. The interval for x for the quadratic. Isn't the quadratic between negative 3 and 3? So I'm going to start with negative 3 and end with 3. That's the values for which we're plotting the quadratic. Does everybody see why I'm choosing to do that? So now from there, let's plug in some other points. Negative 3, negative 2, negative 1, 0, 1, 2. So negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. So plotting points, those points, because that was our interval. So negative 3 up 9, negative 2 up 4, negative 1 up 1, 0, 0, over 1 up 1, over 2 up 4, over 3 up 9. So I'm going to connect my quadratic now. Now what I need to do is go through and say, okay, at negative 3, was it including the quadratic? Sorry, yeah, at negative 3, are we including? No, so watch, I go to negative 3. Locate the quadratic, which is up there. It's not including, so I would open up my circle. Now do you see how you have a closed circle and an open circle on the same point? That's looking good then. Now it says including 3, so I go over to 3, locate the function. It's up there. So it's a closed circle at 3. Any questions on graphing the quadratic? And now moving on to graphing this line. Negative x is this, negative 1x plus 0. So my y-intercept is 0. Just putting dots. My slope is down 1 over 1, down 1 over 1, negative 1 over 1. So watch what I do. Go down to the right one. Down 1 over 1, down 1 over 1, down 1 over 1. Now, aren't we only keeping the line for x values greater than 3? So I'm going to go over to the x value of 3, locate the function. Isn't it right there? So we're keeping it for x values greater than 3. So I'm going to erase these little dots. And then was it including 3? So at 3, I go to my function and I open up my circle. Now let's connect to make sure everything looks good. If I draw straight across, there's no double dipping anywhere. Closed circle, open circle. Closed circle, open circle. And there's no gaps. It's connecting straight through. Questions? As long as you know how to graph stuff, it's not bad. Alright, let's do just one more piecewise function, then we'll be done with graphing these. Okay, so it says you have a line at 3, a straight line with 0 slope at 3 for x values less than negative 1. So I'm going to go up to 3. I could connect all the way through. But aren't we only keeping that for x values less than negative 1? So So I go to -1, go out to the functions. We're keeping it for x values below -1. So now I need to erase the above. It's including -1, so at -1 it's a closed circle. I have just finished that piece. Alright, let's do the square root of x plus 1. Now, square root of x plus 1, let's do an xy chart. You're not going to plot, well, we already actually know what points we need to plot. Doesn't it tell you to go from -1 up to 3? So -1's our starting point, 3 is our ending point. And then you can do some points in between. -1, 0, 1, and 2. So let's plug in a -1 right here. Wouldn't that be the square root of -1 plus 1 is 0? The square root of 0 is 0, right? Let's plug in 0. The square root of 0 plus 1 is the square root of 1, which is? What is the square root of 1? Oh dear. Yes, you're right. Do you guys know that the square root of 1 is 1? Okay, let's plug in a 1. 1 plus 1 is 2. The square root of 2 is a decimal. So let's say you wanted to write down the decimal. You type it into your calculator. The square root of 2, which comes out to be 1.4. Let's plug in a 2. 2 plus 1 is? Square root of 3 is a decimal. You would type it into your calculator. You get 1.7-ish. And then let's plug in 3. That one's easy. 3 plus 1 is 4. The square root of 4 is 2. Let's plot those points. -1 up 0. Over 0 up 1 unit. Over 1 up 1.4 units. Over 2 up 1.7 units. Over 3 up 2 units. So there's the quadratic. We're only graphing it on that interval. Was it including -1? So I go to -1, go to your function, there it is, and you would open up the circle, which makes sense. Closed circle, open circle. Then I go over to 3. The function is right up here at 2, so it's including 3, so I'd have a closed circle. And then lastly here, graphing this line x minus 2, y-intercept is 2, our slope is 1 over 1. So down at -2, I'll just put dots. Up 1 over 1, 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 and so on. But we're only graphing that line for x values greater than 3. So watch what I do. I go over to 3, find the function. Boom, right there. We're keeping it for x values greater than that, but not including. So I go over to 3, find the function. There it is. Open up my circle. Does it meet all the criteria? Does it connect all the way through with closed circles, open circles, not overlapping, no gaps? Yes. All right. Do you have any questions on piecewise functions? Are you sure? Okay. All right. So now we're going to go the other way. This is the only example I'm going to do of this. So everybody, it says write the equation to the piecewise function. So what I want you to notice is there's 1, 2, 3 pieces. So we are going to have 3 equations. 1, 2, there's 3 pieces. Now aren't they all lines? Line, line, line. So all of the equations will have the form mx plus b. Mx plus b. Mx plus b. So to write the piecewise function, we would say, okay, so we have f of x. We have a function equal to, and we draw these little squigglies. It's containing 3 pieces. Sorry, I want a bigger squiggly than that. We have 3 equations. Let's focus on equation number 1. Mx plus b. So let's go find the y-intercept. Where is it crossing the y-axis? 0. So we have plus 0. And then our slope is up 2 over 1, isn't it? And it's a positive line, because if you were to like step on it, you'd be walking uphill. So it's 2x. So our first line is just 2x. We don't need to write plus 0. So 2x. Now we're graphing that for which x values? Where does it start? The x value of 1. So isn't it below below what? So you'd say we're graphing 2x for x values less than 1. Now it is including 1? Yes, because it's at 1, the function is closed circle, including 1.
Pardon the interruption. Can I please get Training Christensen down to the attendance office for checkout, please?
Yep. Hey, moving on to the red line. Now notice the red line doesn't look like it has a y-intercept, but it does. Pretend it did. If it did, where would it cross the y-axis? Continue with the same pattern. Isn't the slope down 1 over 1? So up 1 over 1, so it would be a plus 5. And it's a negative line because I would be sliding downhill. And isn't it down 1 over 1, down 1 over 1? So negative 1x plus 5. So our second equation is negative x plus 5. And what are the x values between? 1 and 4. So watch what I do. I put a 1, I put a 4. Does everybody see? Now it's x values between those. So, and the sign is going to be the same for this. So it's x values greater than 1. So look, it's got an ex greater than 1, not including 1, but below 4, but less than 4. Isn't it also including 4? Or including 4. Okay, moving on to our third equation here. We have a y-intercept of -2, correct? And isn't it a 0 slope? Look, 0x minus 2. So wouldn't that just be -2? All right, and then we're keeping that for x values. Here it is, starting at 4 past, greater than 4. X value is greater than 4, and then it's an open circle, so not including 4. Writing the equation will be pretty easy. It'll all be lines. The piecewise function. Mx plus b, questions on that? Okay. Remind me to never record in this class again. All right. Okay, recall, for something to be a quote-unquote function, it has to pass the vertical line test. Or in other words, each x can only have one y. That is the main important thing. So everybody, if I draw a straight line and it touches my pencil in 2 places, that x value is touching 2 y's. So does this right here, this relation, can it be considered a function? No, look, right here it's crossing in like 1, 2, 3 different places. So it's not a function. But if I did ask you, and I shouldn't have drawn in pink, but oh well, what is the domain? We can still tell the domain. What are the x values here? -5 up to 6, including -5 and 6, because it's a closed circle. Do you agree? What is it ranging between? What's the lowest y value? -2 up to 2. Okay, moving on to this one. Does this one pass the vertical line test? Is this one considered a function? Yeah, each x only has one y. All right, so yes, it's a function. Our domain would be from, it looks like -6 up to 5, isn't it? -6 up to 5. And our range is ranging between, lowest value is -4 up to 4. Okay, good. We're actually almost done with the lesson here. All right, now we just saw that if we have a graph, we can determine if something is a function. But what if we have an equation? By definition, each x can only have one y. That's what makes it a function. So let's look at this equation. Y equals mx plus b. Are lines considered functions? Do they pass the vertical line test? Yes, so that would be considered a function. Is a quadratic looks like this. It's shifted up 1. Does that pass the vertical line test? Yes, quadratics do. Now looking at this one, first of all, notice it's x equals y squared. Now, we like to look at equations as y equals, so let's get y alone. So what would I do to both sides? Square root. When solving and taking a square root, I cannot forget to put a plus or minus. So my equation is y is equal to plus and minus root x. Now let's think about plugging in an x value. If I plug in 1, aren't I going to get out plus or minus 1? So I plugged in an x value of 1 and got out 2 y values, didn't I? Because of the plus or minus. So would this be considered a function? No, there's 2 y values for 1x, not a function. The plus and minus makes it not a function. Everybody see why? Okay, let's do this one. So what would I do to get y alone? Because we like to look at functions with equation. What would we do first? -1. So we have x minus 1 equals y squared, then what? Square root, and I need a plus or minus. So if I was to plug in a value, would I get 2 outputs? Yeah, that would make it not a function. Plus or minus again, do you guys see? So this would be considered not a function. All right, looking at this one, x squared plus y squared equals 4. Would this one be considered a function? Well, let's get it into y equals form. So what would I do first? Subtract x squared, right, everyone? So we would have y squared equals 4 minus x squared. Then what? Square root both sides. Root cancels out with power when solving and taking a square root. Don't I need a plus or minus? So if I was to plug in something, won't I get out to something? Once again. So it's not a function. Alright, but be careful here. Is this one considered a function? Yes. Is there a plus or minus on that? No. So we're all good here. This one would be considered a function. If I plugged in a value for x, I'd only get one output. Okay, awesome. That is the end of the lesson. So you have a ton of in-class time. I need you working on the homework. So I'm not assigning all odds, but I'm assigning these ones. These are the ones you need to do. So write it down first things first. 5 through 27 odds, 33 through 46 odds, 49 through 56 all, 57 through 67 odds, 81 and 83. Now when it says all, that means evens and odds, and you're only going to be able to check the odd answers because in the back of the book, to get the answers, guys, you got to scroll clear to the back of the book, flip clear to the back, find 2.2, and then you can check your answers that way.